Hi folks, so the question we're going to be going over today, guys, is under the topic of road geometry and sometimes called geological geometry. Okay, it is one of the prescribed questions on the Leaving Cert DCG paper and usually comes up as in the section C as question 1. Okay, the area we're actually going to be going over in this video has to do with profile cutting sections. Okay, so basically I'll just read the question and we'll get started on that there now. So it says on question 1, the contour map supplied shows Ireland's highest mountain, Carrauntoohil in County Kerry. This mountain reaches a height of 1,039 meters. Also shown is the neighbouring peak of Beancarra. Okay, the rest of the McKillicuddy Reeks have been omitted from the map. The map shows ground contours at 100 meter intervals. On the map, draw a vertical section profile along the line AB, and our scale is 1:10,000. Okay, so just a little bit on that, guys. We can obviously see the map here, okay, and we can see the topography of the map, okay, and we can see the various contour lines, okay. We can see this one here, it's a little peak here, which is called I think it is Beancarra, okay, and it's 900 meters where we see the contour here. I'm sure it goes up a little bit further, and we can see then that the lowest one is 500, 6, 7, 8, 9 up to 1,000, and we know then that the overall height of it is 1,039. okay, so this is obviously the peak here. And basically you have to kind of understand when you're looking at it, okay, this is the bird's eye view of the map, okay. So we can see here that it's actually sloping from here, it's going downwards, okay. And the reason for that is because if we look at the contour numbers, okay, we can see it starts at 1,000, 900, 800, 7, 6, 5, and obviously down to 4 and so on, okay, until you're basically back at ground level. So what we have to do is we have to do a vertical cutting section through the mountain, and we want to see the profile that will be generated by that vertical cutting section. And we can see the vertical cutting section is shown here in the line AB. So if you imagine you were a person standing here looking in this direction of the pen, and basically we literally slice the mountain straight down like that, okay, from A all the way across to B. And basically then we would kind of see maybe something that kind of is going up and down like that, okay. We would see basically where that cutting section goes through the mountain, and obviously then it goes through it at various heights, 1,000, 9, 8, 7, 6 and so on, okay. And basically we're going to plot the points of where that cutting section actually goes through the mountain and those contours intersect it, okay. The next thing we have to go over then is just on the scale. So for the scale on this sheet, for every 1 millimeter on this sheet, okay, in reality 1 millimeter on the sheet is equal to 10,000 millimeters in reality, okay. So if we break that down, 1 millimeter on the sheet, 10,000 millimeters, another way of saying that would be 10 meters, okay. So 1 millimeter on the sheet is equal to 10 meters in reality. Therefore, a good scale we can work with, if we look over here, the distance between our contours is 100, okay. The gaps between them, say 600 to 500, is 100, okay. So I know if 1 millimeter is equal to 10 meters, therefore 10 millimeters would be equal to 100 meters. Therefore, what I'm going to do is with this cutting section, I'm going to start here, and this is how I usually do it. I'm going to start with the lowest profile, okay, and that there is 500. So I'm going to put 500 here as a little guide. So write that in there. And from this line up here, what I'm actually going to do is I'm going to measure up in 10 millimeter intervals, okay? And I'll do it for 5 or 6 goes. So if you think 500 was along this line here, and if I measure up 10 millimeters, make a little mark, that'll be where 600 is. Next one will be where 700 is, 800, 900, 1,000, okay. So if I put in that, these are light lines now, construction lines, okay, that's 600, 7, 8, 9 and 10, okay. So once again, writing those in, little guides. So that's our 600 meter contour, okay. This will be our 700, this is our 800, 9 and then obviously 1000, and then I'll just put in a little meter symbol there. Okay, the reason for that, as I said guys, is 1 millimeter in reality, or 1 millimeter on our sheet I should say, sorry, is equal to 10,000 in reality. 10,000 millimeters, another way of saying that would be 10 meters, and therefore we have to multiply up to the 100. Okay, so obviously then 10 into 100 is 10 times, so 10 times 1. That's why I went up 10 millimeters here each time. Okay, so what I'm actually going to do now is, okay, this is where technically my contours are, if you imagine they were in front of us. Okay, as I said, and we were looking in this direction. Now what I'm going to do is I'm going to plot the points, okay, along where my contours are cutting. Okay, so there's a point right there. This one is very, very close to it, as we can see, and it's probably meeting it somewhere about here. So I might actually just, if I was to continue that and imagine it, okay, just for demonstration purposes, I might have a point there. I've obviously got another one here. This 900 millimeter or 900 meter one here isn't touching it, okay, the cutting section, so that's not relevant. This one here, that's not here, 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 here. Okay, and what we want to see then is which ones are cutting, and we've got one right here as well. Okay, so starting on this side, okay, I'm going to leave that one out for a second, but starting here, which one is that on? So if I follow the contour over, okay, and I follow it over, I can see that that's actually up at the 700 millimeter, or sorry, 700 meter contour line. So I'm going to mark it up there to the 7. And I can see that there is a point, okay, on my profile. Now what I'm going to do is the same. So the next one I'm going to assume is the 8. Yep. The next one I'm going to assume is, it's actually the 8 again. Okay, so don't assume, as I was just about to say there. So we can see here, this is how high it is at 8, 800, 800. The next one here is still the 800. Yep, just checking that to be sure. Okay, still the 800 there. And then the next one here is the 900. So I know I'm going up to here. Next one is 1000. So I'm going up to the top one, 1000 once again. Then I'm on back down to the 900. Then I think this, just check this one, yeah, it's the 800. Then we're on to the 7. This one is the 6. And it's hard to see there, but obviously outside the 6, which is here, there's a little one here, and if you imagine, we can see obviously the 5 is probably coming back over, so this one is obviously going to be our 5 then. Okay, and looking over here, I know this one here was my 700, okay, so then I'm assuming that this one, okay, that I just put in extra is probably the 600, okay, so I'll just put it in anyway, just to kind of help us. And what we have located here now is a series of points on our profile at their various heights, or their respective heights, okay, on the vertical section. That one there is 5. So what I'm going to do now is I'm just going to speed up the video as I sketch in that profile. Okay. Okay, there we have it guys. That is a profile there, obviously, of the Carrauntoohil mountain, okay, and that essentially, that section there is kind of what you would see, okay, if, as I said, we were to put a slice through it here on the line AB, and that's exactly where it's cutting all of those various contour lines there, okay. So the way to do those questions, guys, is literally, they're not too hard. It's just understanding where people actually can often get caught up is on maybe the scale or something, and just working out how far they're meant to measure up along here, okay. Luckily enough, guys, a lot of these times it's going to be a 5 or a 10, and often it's usually the 10 millimeter one, okay. So what we're going to do now is we're just going to go on to another example of that there, okay. Right guys, so this next question, guys, I forgot to say earlier, is actually from the DCG Solutions workbook, Plain Descriptive Geometry. It's actually the second book, okay. We're actually on page 3 on sheet profiles, okay, just for anyone who's wants to know where we're at and where to get these questions to do them. So the next question we're going on to, guys, is this one down here. It's on page 3, as I said, and the question says at the top up here, the map shows ground contours at 10 meter intervals, so we can see here 10, 20, 30, 40 up to 50. On the map, drawing a vertical section. On the map, draw a vertical section profile along the line AB. So once again, very similar to the last question. We've obviously got a line here AB where it's sliced through the mountain. Okay. Identify and determine the altitude of the highest point on the profile. Okay. So they've given us something a little bit different here. Identify and determine the altitude of the highest point on the profile, and they've also told us the scale is 1:1000. Okay, so first of all, using that scale, that's what we're going to use to help us. 1:1000, so for every 1 millimeter on our page, that is 1,000 millimeters in reality. So in essence, that means 1 millimeter is equal to 1 meter. Okay, so then we also can see that the gaps between them, okay, are 10 meters. So 1 millimeter equals 1 meter. So therefore, I'm going to move up up here when I'm doing my profile in measurements of 10. Okay, so starting off, I'm actually going to start with 10 here at the side because that's my lowest number. So 10 is there, and from there then I'm going to measure up as far as the 50. So in 10 millimeter intervals. So 10, 20, so it's 20, 30, 40, up to 50. There we go. Okay, at that point then, plot in your contour lines. There you have it. Okay, so as I said, this line here, I'm treating that as my 10. At this one is my 20, 30, 40 and 50. Okay, so what we're going to do now is where the line AB, okay, that vertical cutting section goes through my map, okay, I want to find the points on the map where it's going through. So this one right here is cutting onto 10, okay, just following it around because I can see the 10 contour. So at that point right there, project it up to the 10, and I know it's the same over here, but I'll do that. So the next one now is 20, so it goes up to there. Next one is at 30. Then we have 40. Then finally 50. So it goes all the way up to the top. 50 again. And you can see now we're working our way back down. So this one is on the 40. 30. Just make sure. Happy with that, yes. And then 20, and finally 10. Okay, so right now I'm going to speed up the video there, guys, as I plot that profile. Okay, so there we have, guys, that is the vertical profile of the line AB here, represented there, okay? Now, what we have been asked also at the top here, guys, I know you can't see it in the camera, but I'll just read it out. It says, identify and determine the altitude of the highest point on the profile. So looking at that there, guys, okay, as the profile goes from here left to right, we can see that the highest point is up here. So the highest altitude of it is about up there, okay? So that's what I'm going to mark it there, okay? And I'm going to say, okay, just put a little arrow in there, and that is, I'm just going to put in a little H here, which stands for highest, and then altitude. Okay, so we've obviously got highest altitude there, and at that point there, then technically, if I was to bring that back down, is going to be right here on our map, and that kind of does make sense. Okay, so as we can see there, that is the highest altitude on that. Okay, nice easy enough one. Okay, but what they've brought in here is just showing us then that we can also get the altitude from the profile, okay, which is very helpful at times as well. So I'm going to move over here now, guys, to this next question over here on the top right of the page. Right guys, so on this next question here, it says the map shows ground contours at 5 meter intervals, okay, and on the map draw a vertical section profile along the line AB, and we're given a scale of 1:500, okay. So we can see the map here, okay, and we can see that the distance between our contours now in this case has changed a little bit from other questions, and this time the distance between them is 5 meters, okay. So we can see here 50, 45, 40, 35, 30 down and so on, okay. So what we're going to do is we're also going to use a scale that has been given to us. So just working that out there, our scale here 1:500. So in that case guys, and just going to put it in here, 1 millimeter, okay, and that's on page. Alright, so 1 millimeter on your page is equal to 500 millimeters, and that's in reality. Okay, so 1 millimeter on our page is equal to 500 millimeters in reality. Therefore, if we were to work that out and we were to kind of scale that up a little bit, 1 millimeter, if I was to say work this up, because if you think the distance between our contours, this is kind of your little guide here, 50 take 45 is 5 meters. We're trying to work up 500 millimeters up to 5 meters. So what do I need to multiply that by, okay, to make 5 meters? And the answer is 10. Okay, so to make 5 meters, I need to multiply this by 10. So if you think of that by 10, if I multiply this by 10, I also need to multiply this by 10. So 500 would be now 5,000 millimeters. Okay, and that would be in reality. Once again, you get the idea. And then 1 millimeter would be 10. Okay, on the page. So there we have it. Therefore, what we're going to be using once again is 10 millimeters. You might have thought because the scale was a little bit different this time, okay, but it was all dictated by what the contours were in here. So, starting that there guys, we're going to do the same method, okay, and we're going to start our contours. What's our lowest contour is the 20. So in this case, I'm actually going to change it this time just to show you, and I'm going to imagine this one was 15. Okay, and I'm going to measure up then once again in 10 millimeters distances. So this one will be 20, 25, 30. I'll actually change it just based on the space I have in the sheet guys, so apologies for that. I'll switch this one back to 20. Made no difference, I was just thinking I'd keep it on the lower end. So 25, 30, 35, 40, 45. Okay, so there we have it. And just drawing those contour lines as we would see them as horizontal lines. And once again, write in my measurements. So if this is 20, this one's going to be 25, 30, 35, 40 and 45. Okay, so at this point now, once again, we know what to do here. Okay, we're going to plot where the contour lines are cutting through our vertical section profile. So I'm going to work from left to right, and I can see the first one here is actually on 40. Okay, so up to the 40 there. Next one is at the 35. Next one's on the 30. And then 25. And then 20. And then we have 20 again. Okay, 25. Up to 30. And then finally 35. Okay, so there we have it guys. As you can see where I've stopped it on each one. What I'm going to do now is I'm going to quickly speed up the video there as I sketch in the profile. Okay, so there we have it guys. That is the profile. As you can see guys, just for keeping it in the sheet, okay, I was afraid in case it would go up too high up here, okay. probably would have managed. But as you can see here, guys, what's very important is when you have the vertical cutting section going through your contours, we can see we had 20 and 20 here. Now, where students sometimes think is that this will actually just come over as a straight line. You have to kind of imagine reality. There's probably a little dip there. As it goes down, it's probably going to keep going down before it starts to rise again, okay? So that's why I just dipped it a little bit down here in between the 20 marks, okay? So that's that question done there, guys. A little bit different there just on the scale side of things, but remember your scale is very much dictated by what your contour marks are here, okay? So now we're going to move to the question now at the bottom of the page, okay? Right, guys, so the next question we have on this page, it says the map shows ground contours at 10 meter intervals, okay? So just looking at the sheet, okay, so I can see 40, 50, 60, so I know the distance between my contours is 10 meters. On the map, draw a vertical section profile along the line AB. Now in this case we can see, okay, our map is a little bit smaller here and we can see the contours, okay. They're obviously a lot of them are like quite close together. But what we can see also is that the vertical section profile, okay, whereas previously it was kind of going horizontally across our page, now it's just an angled version, okay. So technically what we're doing is we're looking in this direction, okay, in relation to the kind of topography of the map, okay, or the mountain in this case, okay. Wouldn't really call it a mountain when the highest point is 110 meters, but you get the idea, okay. So essentially what we're going to be doing is we're doing a vertical section profile that is parallel to the line AB, okay. Now what we next need to do as always is work out our measurements going upwards. So what we have here now, okay, so 1 meter, our scale is 1:2000. So that means 1 millimeter, which is on our page, once again, is comparison to, or is to 2000 millimeters. That's in reality. Okay, so we know 2000 millimeters and we know the gap is 10 meters, okay, so 2000 millimeters is equal to 2 meters, and obviously 2 we need to work up to 10. So what do I need to multiply this by to get up to 10 meters? And the answer is 5. Therefore 5 times 1, you can see how where we're going with this, so 5 millimeters on our page would equal to 10,000 millimeters in reality, okay. So you get the idea. So this time we're actually doing something a bit different here based on the scale and the contours that we had. Now we're going to go up in 5 millimeter intervals, okay. So in doing this question, I'm going to start off, going to look at my contours, see what my lowest one is. The lowest on this side is 40 and you can see it's working back way up, highest 110, back down to 40, okay. So what I'm going to do is right here off the edge, parallel to the AB, which is at 45 degrees, okay, and do a cutting section like that, okay, and that one there I'm going to mark that as my 40, okay, and continue on then in 5 millimeters. So just measuring out in 5 millimeters, so this will be 50, 60, 70, 80, 90, 100, 110. So at all those marks I'm literally going to do parallel lines. So there's 50, 60, 70, 80, 90, 100, and finally 110. And once again, writing it in at the side as well. So 50, 60, 70, 80, 90, 100, and 110. Okay, so now what we're going to do is simply plot those points. So I'm going to start reading it from this direction. So perpendicular. Let's make sure, yeah, out there. So perpendicular. So at the 40 mark here, see where it's cutting through the section. That's going to go up to my 40. Then the next one is the 50. It's the next line up. 60. Should be the third one up, yes. Just make sure, yeah, 70 here. Just make sure I'm going up to the right ones, yeah. Follow it down, yeah. The next one is 80. just check it to be sure. So 40, 50, 60, 70, 80 is up to there. The next one is going to be on the 90. 40, 50, 60, 70, 80, 90. Okay. And then the next one where it cuts through is actually on the 100. And then we've got two at 110 then. So this one's at the 100. So 40, 50, 60, 70, 80, 90, 100. Then I got two marks on the 110. So that's all the way to the top. Okay. And the next one going down is 100 again. Then we have a 90. You can see the contours are getting quite close here. Okay. Therefore, it is actually quite steep. Okay. We can see that it will be very steep here. So based off this, just make sure, yeah. So 80, 70, 60 down. So we're going down to 80, which is there. Just use this as a guide, but I'm pretty sure, yeah. Then we have 70. Then 60. There you have it, guys. That is the topography of it, okay, and the profile of it. So I'm just going to sketch that in there again. Okay. There we have it, guys. That there is the profile of that answer there for that question, okay? As you can see, I said there, guys, when you see that the contours are very, very close together, okay? That's going to show you then that you can actually see here it is quite steep. Whereas on this side, obviously, of the mountain, okay, or the hill or whatever it is, you can see here it is a lot more gradual, okay? Very steep on this side where the contours are close together, whereas when they're spaced out, it's going to be more of a gradual decline, okay? I hope you found that helpful, guys. That's that question completed there.